Introducing DETecTiVeD, a Socratic-Technology integrated, critical thinking model for physics based on Bloom's digital taxonomy. Hi, Assalamualaikum and Salam Sejahtera. I'm Fatina binti Muhammad Rafi and my colleague Muhammad Izzat Iqbal Muhammad Zaha. We are from College Matrikulasi Selangor. We present a paper for International Action Research Competition 2022. As we are moving towards the new normal in the post-COVID-19 era, which has affected education sector worldwide, there is urgent need for the education sector to evolve. Critical thinking has been identified as one of the most important skills needed to survive industrial revolution. However, as can be seen on this slide, statistics show high percentage of low-level critical thinking among students in university, matriculation, as well as students in secondary school. Many methods has been done to tackle this issue, and Socratic model of learning has been identified as one of the effective methods to induce critical thinking among students. Therefore, this study focused at developing a critical thinking model based on Bloom's digital taxonomy by integrating Socratic method and technology in physics lesson. Objectives of this study are to develop, verify, and then evaluate a critical thinking model based on the theory of Bloom's taxonomy and Socratic method. This study will start off by using literature review method in order to develop a critical thinking model for physics. The developed model is then verified using expert review method to collect feedback on the three components of the model: structure, effectiveness, and usability. Next, to evaluate the developed model, quasi-experimental research design is used on 50 physics matriculation students, which are categorized equally into control and experimental groups. Using topic of uniform circular motion, students in experimental group undergo learning process by using the model as a guideline to Socratic questioning session. After 2 weeks of continuous learning using the model, they were given an assessment to assess their conceptual understanding. Then, ANOVA tests were made using SPSS for analysis purposes. Let's now look at the findings. A model is developed as shown in the slide here after reviewing literatures on Socratic method, physics learning, Paul Elder framework, as well as Bloom's digital taxonomy. The model consists of 3 stages: introductory, main, and conclusive. These 3 stages are in line with Paul Elder critical thinking framework. The introductory stage, stage 1, serves as introduction of any chosen concept to be discussed. Since physics is best learned by hands-on, thus in stage 2, which is the main stage of the model, students will undergo a mini investigation. This stage ends with verification process of proving the concept either by using formula, equation, law, or principle. In the last stage, stage 3, students will dig deeper on their conceptual knowledge by asking them set of out-of-box questions. All levels and stages in the model is designed to be used as a guideline when conducting Socratic questioning during physics lesson as a way to induce students' critical thinking. Verification process on the developed model is done via expert review method. The result of the questionnaire shows a mean value of 4.5 out of 5, where all 5 experts agreed with the structure, effectiveness, and usability of the model. However, some amendments were encouraged to be made in order to improve the model. Major adjustment can be seen at stage 3 of the model, where the term evaluate is changed to design so that it aligns with the highest level of Bloom's taxonomy. This process is where students are asked to create a similar situation that they could further investigate on the same concept introduced in stage 1. The structure of the model is also modified. You can refer to the right side of the figure here, in order to make integration of technology in the model more flexible and feasible. The model named DETecTiVeD, in which the acronym is taken from each level. The meaning of detective itself means someone whose job is to investigate, which is in line with the main stage of this model. As previously mentioned, an assessment of conceptual question on topic uniform circular motion is given to both control and experimental group. To avoid researcher bias, the analysis is done by categorizing students into low and high performing groups. For low performance students, as seen on the graph on the left here, if you compare the peak of the curve for both groups, results shows that experimental group achieves a higher level. Now, if you look at the figure on the right, which represent high-performing students, the experimental group peaks lies in good category. However, there are two peaks for control group, which lies at poor and good category. Now, let's look at this ANOVA test results. Blue represent high-performing students, red represent low-performing students. We can see that the difference between control and experiment average is 1.54 for high-performing students and 3.8 for low-performing students. The graph is also observed to be much steeper for low-performing students, which indicates stark difference in mean value. To conclude, these results indicate students who undergoes process of detective model in their physics lesson achieve higher marks. Study also found that this trend shows a much significant improvement for low-performing students. In this preliminary study, we can conclude that detective model can be used as a guideline to Socratic questioning in physics lesson, as it has shown to increase students' ability to answer conceptual questions, which in line with ability for one to think critically. In addition to that, this study has also found that low-performing students shows more significant improvement after the model is applied to them compared to high-performing students. Hands-on investigation components in stage 2 of the model is believed to be the novelty point in this study to enhance physics learning session to induce students' critical thinking. Bloom's digital taxonomy integrated into the learning session will spark creativity that enhance the learning process. In addition to that, DETecTiVeD model can be used not only to physics lecturers, also to lecturers of other subjects. And with sufficient practice, students themselves can apply this model in their self-learning process. For future works, we are hoping to extend this model by incorporating artificial intelligence into the model so that learning process can be accomplished independently by students. With that, thank you very much.